All right, so example one, if you're doing this lesson on your own, you're gonna watch this video, you're gonna see me do it, and then you're gonna try to do it on your own on the next slide. And you can refer back to this video if you forgot or you need to check your work. So again, we're always annotating, so we need to rotate 90 degrees counterclockwise about the origin. Don't worry about the origin right now. All of our rotations are about the origin. When it changes, that's when I'll explain to you what that means, because then it'll make sense. So going back to my notes, 90 degrees means I'm only moving one quadrant. So let me label my quadrants. 1, 2. Actually, let me not label it there. It might be in the way of my picture. So 1, 2, 3, and 4. And counterclockwise goes in order for the quadrants. So I'm starting in quadrant 1. So counterclockwise, I need to end up in quadrant 2. So you're going to make a note of that. I'm ending up in quadrant 2, and in quadrant 2, x is negative and y is positive. Okay? Let's go ahead and get these ordered pairs out of the way, because it's actually better to do the ordered pairs first. You can't do the rotation, the picture first. You can't do the drawing first. There's really no way to understand where it's going to be, so we've got to do the ordered pairs first. So x is located at 1, 1. Y is located at, oh, I hate when they're not numbered. 1, 2, 3, 4, 3. And z is located at 3, 5. So for a 90-degree rotation, everything is going to switch. So I don't even need to worry about signs. I'm just going to switch everything, but this is the same. 4, 3 becomes 3, 4. And 3, 5 becomes 5, 3. Now, I'm going to be in quadrant 2. So that means x's are negative. Y's stay positive. Now I have my ordered pairs. I'm going to plot them and then connect my points. So negative 1, 1. Negative 3, 1, 2, 3, 4. And negative 5, 1, 2, 3. Again, on Pear Deck, use the line function so your lines are straight. But it should be up here in quadrant 2. It should be now facing a different direction. So this is what your rotation of this triangle looks like.